Hello everyone, welcome to the part 2 of the AMC 8 2026 problems. Today I'll be covering problems 11 through 17, and once again I'll be going through full competition speed, so if you need, please pause and think it through if I'm going too fast. Alright, let's get into it. Problem 11. Squares of side length 1, 1, 2, 3, and 5 are arranged to form the rectangle below. A curve is drawn by inscribing a quarter circle in each square and joining the quarter circles in order from shortest to longest. What is the length of the curve? So this is just the sum of a bunch of quarter circles of length in order 1, 1, 2, 3, and 5. The perimeter of a circle is 2 pi r, where r is the radius. So since this is a quarter circle, we're going to divide by 4. So we want the sum 2 pi times 1 over 2, 2 pi times 1 over 2, plus 2 pi times 2 over 2, and so on. We can just actually use the distributive property to pull this 2 pi over 4. Sorry, this should be 4. We can pull this out over here to get 2 pi over 4 times 1 plus 1 plus 2 plus 3 plus 5 to get the entire perimeter. So that is going to be, cancel this out, pi over 2 times 1 plus 1 is 2 plus 2 is 4 plus 3 is 7 plus 5 is 12. Pi over 2 times 12 is just 6 pi. So our answer is B. Problem 12. In the figure below, each circle will be filled with a digit from 1 to 6. Each digit must appear exactly once. The sum of the digits in neighboring circles is shown in the box between them. What digit must be placed in the top circle? So for these limiting problems, we want to find a parameter that most limits the possibilities of these 6 digits. So we see that the max sum of any of these numbers can be 5 plus 6, which is 11. So any of these numbers in the squares has a maximum of 11. And we see a 10 there. So we think to see where the largest number in a circle could be, which number should 6 be placed in. So I'll just draw this kind of here. So these sum to 9, 10, 8, 5, 4, and 6. So which number can 6 be placed into? Let's try this one. Can this be put into? No, because we already have a 6 here. So then if this is 6, then this number must be 0. So this is impossible. That also means that every circle neighboring a number that's less than or equal to 6 cannot be possible. If this number is 6, then this number is negative 2, which is also not possible. Which means 6 cannot be in here, 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 or here. So that narrows it down by quite a lot, actually. So it must be in these 2 circles. Let's say it's here. Say 6 is here, then this would be 3, 3. That would not work because we cannot have duplicates. Each circle has a different number. So that must mean 6 is in here. So let's try it. 6, 4 plus 5 is 9, 5 plus 1 is 6, 1 plus 3 is 4, and 2 plus 3 equals 5. So this does indeed work. The top digit is 5, so 5 is the answer. 5D. Problem 13. The figure below shows tallying of 11 unit squares. Each row of unit squares is shifted horizontally by half a unit relative to the row above it. And there's a square shaded. And I'll just let you look at the diagram itself. Okay, so I'm going to draw this to form this square. My drawing is not perfect, but this problem is actually a lot easier than it looks. It doesn't matter that these rows are shifted this way and this way. What only matters is the side length of the square, and it's given as a square, so we can just use if S is the side length, then S squared is the area. So we can just look at this right triangle here. This is a right triangle with legs 3 and 1 because these are unit squares. So the Pythagorean theorem tells us that the hypotenuse is 1 squared plus 3 squared, square root equals square root of 10. So the area is this squared, which is 10. So the answer is A, 10. All right, next, problem 14. Jamie picked 3 equally spaced integers on the number line. The sum of the first and second is 40, while the sum of the second and third is 60. What is the sum of all 3 numbers? I'm going to draw a number line here because that's what they said. It would also be easier to visualize. Let's label these A, B, and C. So these 2 lengths are equal. So what you'll notice is that B is the average of A and C because it's right in the middle. So we can write the relationship B equals A plus C over 2. This is just the average of A and C. We're given that A plus B equals 40 and B plus C is 60. So we have 3 equations, 3 unknowns. So this is a solvable equation. And the most elegant way to do this is to add these two. A plus B and B plus C, add them. 40 and 60, add them. So you get A plus 2B plus C equals 40 plus 60 is 100. And A plus C, we can rewrite this as A plus C equals 2B. So if we substitute this into here, we actually get A plus C equals 2B. Add that to the 2B that's already there, so we get 4B, which means B equals 25. And from this, you can just plug this into these 2 equations to get A equals 15, C equals 35, right? And we actually don't need to find A and C because A plus B plus C is what they're asking for. And once again, we can just substitute this into here to get B plus 2B equals 3B, which B is 25, so this is 75. So our answer is B, 75. Problem 15. Elijah has a large collection of identical wooden cubes, which are white on 4 sides and gray on 2 sides that share an edge. So first, with these 3D problems, it's always good to draw some diagram. So let's say this and this are the shaded ones. And the figure shows 2 cubes being glued together, leaving three gray faces visible, with the fewest number of cubes that he could glue together to ensure that no gray faces are visible, no matter how he rotates the figure. So this problem is in 2D, or it is in 3D, but we can actually reduce it to 2D. Instead of imagining a cube with two adjacent gray faces, we can turn this into a square with two adjacent gray faces, gray sides. So I'm just going to say these are gray. So we have a bunch of these squares with these gray sides. And one intuitive way is to put these gray sides together. So what we can do is put these together like so. So now we have two gray faces here and these two gray faces together. And now we can just mirror this, flip this on the other side to get these two squares with gray faces like this. So now all four gray faces are facing each other, which means the entire outside perimeter is good. And there are four cubes here, and conveniently, 4 is the lowest answer. So we don't have to prove or worry about any lower number. So 4 is the answer. Problem 16. Consider all positive 4-digit integers consisting of only even digits. What fraction of these integers are divisible by 4? If you remember the divisibility rule of 4, let's say 456, we only care about these two final digits. If 56 is divisible by 4, then this whole number would be divisible by 4. 56 is indeed 4 times 14, so it is. So this whole number is divisible by 4. And this also means that we only have to care about if we have four digits here, we only have to care about these last two digits. So these 2 digits are effectively useless. So we can turn the problem into consider all positive 2-digit integers consisting of only even digits. What fraction of these are divisible by 4? And we can do this because the value of these digits, these two first digits, don't change its divisibility. So this type of thing will make seemingly hard questions more manageable. So let's try some digits. So I'm just going to list 0, 2, 4, 6, 8 as the 5 digits we can use. If this is 0, then it turns out 0, 2, 4, 6, 8, they all work as digits. And adding 4 to this final digit also doesn't change whether it's divisible by 4 or not. So that means 0, 2, 4, 6, 8 can be paired up anyway with digits 0, 4, 8. For example, 28 is divisible, 64 is divisible, 80 is divisible. So this already gives 5 possibilities for this one, 3 possibilities for this one. That's 15. Now let's try 2 and 6. But no matter how we try it, 62, 42, 22, 02, 82, they're all not divisible by 4. And that's because changing the tens digit also doesn't change whether it's divisible by 4 or not, because 20 is divisible by 4. And similarly, this means 6 is also not a possibility. So we have exactly 15 possibilities for the last 2 digits. And there's the total amount is 5 times 5, which is 25, because it's 5 for the first one, 5 possibilities for the second one. So the answer, it's asking for the fraction of these integers. So that would be 15 over 25 equals 3 over 5. So the answer is D. Next, problem 17. 4 students are seated in a row. They chat with people sitting next to them, then arrange themselves so that they're no longer seated next to any of the same people. How many rearrangements are possible? I'm gonna label these guys persons 1, 2, 3, and 4, just for simplicity. So we want a rearrangement such as let's say 1, 2, 3, 4, like this, such that no 2 neighboring numbers are consecutive. So for example, 1, 2, 4, 3 is not allowed because 1 and 2 are consecutive. 3 and 4 are consecutive. So this is not allowed. So it's kind of like a snake, if you imagine. 1 goes to 2, 2 goes to 3, and 3 goes to 4. And none of these chains or loops are consecutive. So let's try casework. Let's say 1 is in the first position. 1 is in the original spot as before. Then we would have 1 and here. 2 must be either this or this. If it's here, then 3 can't go in either of these because it's consecutive. If we try this, 3 must be here, but 4 must be next to 3, so that also doesn't work. And if you mirror this on the other side, then it's just the same thing. 1 still can't be on the edge, so we don't have to worry about that at all. And now let's consider this case. 1 is here. There's only 1 spot for 2, which is here. Only 1 spot for 3, which is here. There's only 1 spot for 4. So this is the example that we had here. And because it's so, because there's so many limitations, this is the only option where 1 is in the second position. 1 is in this position. So we can just mirror this to get 1, 2, 3, 4, like this. And this also shows that there's no more possible options for any arrangements. It's just these two, because we prove that 1 cannot be in the first position, only 1 possibility for 1 being in the second position, and by symmetry, flip it around this axis. You just multiply it by 2, so the answer is 2. Surprisingly, the lowest answer there is. Alright, thank you guys for watching. Next video, I'll cover 18 through 22.